I'm sure you've heard the rumor that if our Earth were 1 centimeter closer to the Sun, our Earth would burn. Or if it were 1 centimeter further away, then it would freeze. In fact, this claim is completely unfounded, because the Earth already moves 5 million kilometers away from and closer to the Sun in a year due to its elliptical orbit. That is why this is the case. The rumor among the public is not true, but if you want, I can tell you something much more interesting than this. In the universe we live in, there are values determined with such precise measurements that if these were not even 1 centimeter, but 1 trillion times 1 trillion times 1 trillion times 1 trillion times 1 trillionth of a centimeter, it would change not only in the world, but also in the world. There would never be life anywhere in the universe. There are 4 fundamental forces in physics: gravitational force, electromagnetic force, weak nuclear force, and strong nuclear force. Since the birth of the universe, which we call the Big Bang, for 13.8 billion years, all matter in the universe is maintained by the laws and constants of physics. We already know that the speeds or powers of the laws of physics are constant values. But the first point that surprised us was this. When we came to the second half of the 20th century, that is, in the 1970s, for the first time, physicists asked a question and started to research what is the probability of the formation of chemistry that can create complex systems, that is, create life, and this research. It was like a breaking point, because the physicists who investigated this question realized that the probability of the formation of chemistry that can form complex systems is in a very finely tuned balance at scales that are much lower than we can predict. That's why they called it the fine-tuning argument, and it was written for the first time in the form of scientific articles by Martin Rees, one of England's most famous astrophysicists, and was accepted and published in world-renowned science journals such as Nature, and made a great impact in the scientific world. Because with this research, we understood that if there were no physical laws in the universe, or the current constants would not exist. If they did not exist, life would never be able to form anywhere in the universe. If you want, let's examine this a little more closely with examples. For example, there is a force called gravitational force in the universe. That is, everything that has mass bends space-time and pulls matter towards itself. If this gravitational force did not exist, hydrogen and helium would come together. Stars cannot form. Without stars, heavy metals such as carbon, calcium, and iron that form planets could not form. Elements and chemistry could not form. Well, the absence of chemistry means, of course, the absence of life. That is, if there was no gravitational force, there would be no life. Or let's look at the electromagnetic force. The electromagnetic force is the force of electrons that enable the formation of atoms. It is the magnetic force that makes protons rotate around them. If this electromagnetic force did not exist, atoms could not be formed, chemical bonds could not be formed, light could not be formed, and therefore life would not exist. What we say also applies to the strong nuclear force, because the strong nuclear force holds together the protons and neutrons that make up the atom, and even the quarks inside that make up the protons. If there were no strong nuclear force, no atoms other than hydrogen could form, chemistry could not form, and life could not form. Or if it were not for the weak nuclear force, stars cannot burn their fuel, heavy elements cannot form, chemistry cannot form, because it governs the radioactive decays in the nucleus of the atom. Therefore, there would be no life in the universe. Each of them must exist. More interestingly, it is not enough to have these forces. These forces must also be in precise settings. For example, if the gravitational constant decreases by 1 in 10 to the 60th power, that is, if it decreases by only 1 unit in a number with 60 zeros behind the 1, there will be more than a football in the universe. No large planet could form. If the gravitational constant increased by 10 to the 6th power, there would be large planets, but there would still be no living creatures on those planets, because they would immediately disintegrate and collapse inwards due to the intensity of gravity, but it is set on such a sensitive scale that it is impossible to attribute this to chance. It seems that philosopher Robin Collins even describes the impossibility of this being a coincidence with an analogy. Put a coin anywhere in the universe and shoot it in a random direction. Let the bullet continue without losing momentum. Your probability of hitting that coin at the end of the universe is due to the effect of gravity. Or let's look at the cosmological constant, which is the expansion rate of the universe. If it increases by 1 in 10 to the 12th power, we are talking about a number with 120 zeros behind it. You can compare it with 10 to the 20th power, which is the number of seconds. If this cosmological constant increases by 1 in 10 to the 12th power, the universe will literally scatter around, and therefore neither matter, stars, elements, nor life can form. Or if the cosmological constant decreases by 1 in 10 to the 12th power this time. In the future, the universe would collapse into itself, and neither atoms nor stars could form, that is, life could not form. We can understand this better with an example. Let's think of a ruler that is divided into units of trillionths of a trillionth of a centimeter, and whose length is the width of space, that is, 93 billion light years. In order for it to form, the scale must be brought to a single place. Life cannot form anywhere else, and we see that for some reason, the value of the cosmological constant has been brought exactly there. Let's give an example from the fine-tuning of the initial entropy of the universe. According to Oxford physicist Professor Pina, the distribution of mass energy distribution in a way that allows life. 1 to 1 to the 10 to the 123. Look, this is the highest number ever seen in the history of physics. It is even impossible to write this number, because there are more limits in this number than the number of particles in the entire universe. That is, even if we add up the protons, electrons, and neutrons in the universe, we still cannot reach this number, because the estimated total number in the universe, the number of particles, is 10 to the power of 87d. That is, this number is 10 to the power of 10 to the power of 123. Even if we write 0 on each electron and proton in the universe, we still cannot write this number. But we see that if the initial entropy of the universe differs even by 10 to the power of 10 to the power of 123, life cannot be formed. The settings are too extraordinary to be given to chance, because in a situation where probabilities for a certain purpose are chosen among high odds, the most logical thing is to look for a consciousness behind it. For example, if a person wins the national lottery 50 billion times in a row, would we call this event a coincidence, or would we look for a purpose or consciousness behind it? This is much more likely to happen next to the example we gave. In other words, we are talking about a sensitive setting of a value that you cannot even reach a billionth of a billionth of a billionth for an hour continuously. Of course, after this discovery made in physics, many scientists said that this sensitive setting was transferred to the universe by the creator of the universe. They accepted it as a signature, and this discovery in the scientific world caused many atheist scientists to accept the creator. Even if they did not believe, many atheist physicists admitted that the most reasonable interpretation that could be given to this should not be a coincidence, but a design arranged by the divine power. Years ago, I was a convinced atheist. I never in my wildest dreams imagined that one day I would be writing a book to show that the central claims of Judeo-Christian theology are, in fact, true, that these claims are straightforward deductions of the laws of physics as we now understand them. I've been forced to proceed on a purely natural level, without any reference to supernatural phenomena. In short, my discovery of the divine has been a pilgrimage of reason, not of faith. The integrated complexity of life itself, which is far more complex than the physical universe, can only be explained in terms of an intelligent source. I do not believe that any scientist who examined the evidence would fail to draw the inference that the laws of nuclear physics have been deliberately designed with regard to the consequences they produce inside stars. For the scientist who has lived by faith in the power of reason, the story ends like a bad dream. He has scaled the mountains of ignorance. He is about to conquer the highest peak. As he pulls himself over the final rock, he is greeted by a band of theologians who have been sitting there for centuries. If the rate of expansion 1 second after the Big Bang had been smaller by even 1 part in a million, the universe would have recollapsed before it ever reached its present state. The surprising fact is the values of these numbers seem to be tuned very precisely to ensure the development of life. That's right. That's the one which is really on a knife edge. It is on such a narrow knife edge that it's almost inconceivable. If you were to change it just the tiniest bit, we couldn't be here. Whatever made the universe, I hate to say whoever made the universe, but whoever made the universe made it with eyes. That is because of the fine-tuning. As one of the options suggests, are the sensitive settings the result of a coincidence? I think there is no need to deceive ourselves. Instead, it is the most reasonable and logical thing for us to know our Lord, who wants to introduce himself through this book and the universe.